All right, let's see here. We are planning to make an open rectangular box from a 10 by 18 centimeter piece of cardboard by cutting congruent squares from the corners and folding up the sides. Dimensions of the box, largest volume. What is the volume? All right, so we said 10 by 18. So that's that's what I'm making. So this is x, and 18 minus 2x, x, and x, and 10 minus 2x. So it was 10 minus 2 x's, was 18 minus 2 x's. Our volume is going to be length times width times height. And our length will be 18 minus 2x. And our width will be 10 minus 2x. And our height will be x. So that'll be 180 minus 20 minus 20x minus 36x plus 4x squared all times x will be 180x minus 56x squared plus 4x cubed. There we are. And we want to find ourselves a minimum, so v prime of x. First derivative be 180 minus 112x plus 12x squared. And we'll set that equal to 0. Let's see. Is this divisible by 3? No, we'll see. So this would be, we'll just bring this down a little bit because we don't have a calculator. Minus 56x plus 6x squared, 45 minus 28 x plus 3 x squared equals 0. So 3 times 45 is 120, 135. Two numbers that multiply to 135. That's going to be negative and a negative. 28, so how about 14 and 2, 7 and 4? None of that looks happy, does it? Nope, nope, nope. Negative b plus or minus the square root of b squared minus 4ac over 2a. That's 28. Let's see. That'll be 28 squared minus 12 times 45, 244. And 244 divided by 4. 61. Nothing happy. Okay. Square root of 244. 15. So 28 minus and then divide everything by 6. X equals 2.063. And see, what did we do? We took 28 minus that, we did 28 plus that. 28 plus square root of 244. That divided by 6 is 7.27. And 7.27 is not a reasonable figure because we took this is 7 and this is 7. That makes 14, and we only had 10 to start with. So 2.03. So the dimensions of the box, let's say this is approximately 2. I'm not going to be picky. Approximately 2. So the dimensions of this box are going to be 2, 2, 2, 2. It's going to be 18, 16, 14 by 6. Approximately 6 by 14. If this is the AP test, go ahead and put on some decimals, but I'm not overly concerned. So that would be approximately 84. No, 6 centimeters, approximately centimeters. There we go. 84. All right. That wasn't so bad. Now, assume that f is continuous on -4 to 4 and differentiable on -4 to 4. Table gives some value of f prime of x. Estimate where f is increasing, decreasing, and has local extrema. All right. So this is f prime. So any place that f prime is negative, that means we're decreasing. So we're decreasing, we're getting more and more negative. So we're decreasing, but then all of a sudden we're increasing. So let's say in between here is when we switch over. So we're going down, 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 down. And we switch over, have a flat equal to do you mind? Where was I? Oh yeah. Going down, 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 down. We're pretty much 0 here. We're flat, and then we go up, 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 up. And then we kind of, and that up, we start again. Then we start to go down again. Alright. So where are we increasing? Increasing from what looks like in between, from
increasing from -2.5 all the way to 3. So we're decreasing from -infinity decreasing from -infinity to -2.5, and then we are in.
What are you two supposed to get? Go away. You have plenty of food. Decreasing again after 3. So union 3 to infinity. All right. So local extrema. So local minimum would be right here. So we're decreasing, then increasing. So local minimum at negative 2.5. We're increasing, decreasing. Local maximum here at, this was 3. Find a quadratic regression for the equation for the data in the table. Okay. Not sure. Let's see. Negative 4. Negative 3. 2. That would be 55. Obviously, you can fast forward through a lot of this. Oops. Negative 22. Negative 3. All right, so they're doing a quadration here because it kind of looks like a cubic because we got two extreme max and a min. Looks like a negative cubic, so its first derivative would be so we're graphing the derivative of the function in hopes of graphing the derivative of the function in hopes of I guess the next point is to find the inflection points or something like that. Where were they? 2 gets you 20. 3 gets you 0. Alright, so there we are. Go to stat, calc, quadratic regression. I think it automatically does L1, L2, but just in case. Oops. That's what we wind up with. And quadratic regression is, that would be f prime of x equals approximately negative 4.86 and 4.87 x squared plus 2.85 x plus 31.24. That looks like a double, but it's supposed to be a single. Prime. There we go. That's approximately that. And use the model and B to find a formula for f that satisfies of 0 equals 0. Okay. So, let's see. Need to find an equation. So, look at it is negative 4.7 divided by 3, and then plus 2.85 x divided by 2. Plus 31.24. That's what we did. So we took our values, we upped this by 1 and then divided that by 3, up this by 2, divided it by 2, up this by 1, divided it by 1. And if this equals 0, then 0, all these go to 0, so C just equals 0. So we can just keep all this. Because if this equals 0, this equals 0. Sorry, if this equals 0, this equals 0. All these go to 0. For this to be true, we plug in 0 here, and we're left with f of 0 equals 0, because 0 is C. Alright. I don't know how to explain that, but that's the way it is. Oh shit. Well. So we'll just keep those. So we need to divide x. So f x. So 4.87 divided by 3 is going to be negative 1.5. Negative 1.62 x cubed plus 285 divided by 2 would be 1.42, and 31.4 would be 15.62. Alright, so there we go. It's a plus, not a 7. Alright.